Let's now examine how a multi-tiered architecture might be organized, because some people might think of this as being the tiering. If we think of our client requests coming in from the internet, so we'll make this a request right here. The most simple system is that we have a server that also has connected on it some sort of database. And I'm going to put that down here for now because I want to be able to put other stuff in here. But this is logically one system. And the cool thing is that our system is going to contain that logical nature. So just because to the outside world this looks like one system doesn't mean that we can't change how the system works. And so we're going to build more and more complexity from this logical system right here. So we've got a server and it's got access to the database. Now, one of the first things that we are going to run into when we start talking about dealing with scale, and when we're talking about scaling an application, what we mean is being able to handle a ton of requests because so many people are accessing it at the same time, is that this server or this database, but let's talk about the server first, can't respond to all the incoming requests quickly enough. And so the first thing we can do is we can replicate that. So we can make a server, I'll call this server 1, and this is server 2. And they will do the same behavior as our original server did. And so they may need to have to talk to the database. They may have to check if the person who's making the request is authorized. They may have to format the data, generate JavaScript or CSS or whatever. And now we have roughly doubled our ability to handle requests. And as long as our network bandwidth is sufficient, we now can handle more requests. And if that's not enough, we can throw another server in there and make server 3. And we can keep going in this direction. We can make as many servers as we want. The interesting thing here is that we still want this to look like one logical server. So we don't want to expose to the outside world that we've got these servers here in place. So what we're going to do is we're going to put in what we're going to call a proxy. And this box right here is going to appear to be the server to the outside world. But what it does is it knows how busy each of our boxes is. So we have 3 boxes here. So it says, oh, box number 1 is handling 50 requests right now. Box number 3 only has 10 requests, and box number 2 has, let's say, 35 requests. So because of that, I think box number 3 can handle another request. So I'm going to route the next request to box number 3 because I think it can handle that request more easily than box 1 or box 2. And the proxy's job, all it does is takes the request that it receives, does some quick calculation like we just talked about here, and decides to forward the request to this box over here. And it's a guess because some requests are easier to satisfy than others, and so maybe the request that we did will be able to be answered quickly. Maybe it will take a long time. We don't care as long as all the requests tend to respond rather quickly. If they don't, we'll have some sort of system in place to add another server or something like this. And so we can have this layering in place where we have this reverse proxy and we have these servers set up, and the number of these servers can be quite large if we need to. I'm talking hundreds or thousands of them if necessary, because the work that this one is doing hopefully is independent of this one. That's the whole point of our stateless web server, is that we don't need to remember what the web browser was doing. And so one request can be routed here, the next request can be routed here, the next request can be routed to server number 500. It doesn't matter. We just get the first available server that has that information. And this is our first attempt to try to increase the efficiency of our system, and works pretty well as long as our network can handle it.